All right, let's see if we can take our values for E naught for a cell and calculate a delta G naught to figure out how much useful work, as well as determine the equilibrium constant. Now we know that E naught for a cell is always going to be E naught at the cathode minus E naught at the anode. We know that if this value is positive, your cell is spontaneous. We know if this value is negative, your cell is going to be non-spontaneous. Now we also know for delta G naught that delta G naught for a spontaneous cell is negative, and delta G naught for a non-spontaneous cell or non-spontaneous reaction here is going to be positive. So we should be able to relate our E's and our delta G's and our K's. So what is our equation? Our equation here is that delta G, and we're going to work here at standard state, is equal to minus NF E naught. Now the negative here changes the sign and goes from spontaneous positive to a nice negative delta G. N is equal to the number of moles of electrons transferred. We're going to need to make sure that our reaction is balanced when we use this. F is Faraday's constant. It is a constant and it will be given. And it is 96,485 coulombs, which is our unit of charge for every mole of electrons. And we're going to remember here that our cell potential, E naught, is going to be in units of volts. And a volt is a unit that is a joule unit of work per coulomb, which is going to be our unit of charge. So it's going to tell us, again, how many moles of electrons and how much charge we can get out of this. So we can relate E naught to delta G, and we remember that delta G naught is equal to minus RT times the natural log of the equilibrium constant. So if we can get delta G, we can now get the equilibrium constant. So let's do one. So let's take the reaction where iron 2 plus, Fe2 plus, is going to go into Fe as a solid. Now that's going to gain 2 electrons. This is gaining electrons, and so therefore this is going to be our cathode. And remember that E naught for the cell is going to equal E naught at the cathode minus E naught at the anode. And our anode here is going to be silver losing electrons. And when it does that, it's going to go into Ag plus an electron. Now, we have to balance our reaction for this to occur. Silver is going to lose 1, iron is going to gain 2. So we're going to have to multiply this reaction to get 2 electrons that are going to be lost. So here, and gained, N is going to equal 2. Now, to make this work, we've got to find our cell potentials for the half reactions off of our chart. So to do this, again, remember that Fe2 plus is going to be the cathode and Ag is going to be the anode. So we need to find these reactions on the chart. So as we go down here, the first one we find is Ag plus an electron goes into Ag. Now note, we were told that this is going to be our anode. Well, that's not changing. It's still going to be the anode. And our cathode is Fe2 plus 2 electrons goes into Fe. And this is our cathode. Now, if you look at this, you say to yourself, well, this is backwards. And you're right, because this cell is not spontaneous. This is going to be an electrolytic cell, which means it's non-spontaneous, and we're going to have a negative value for E naught. Now, E naught is still going to equal E naught at the cathode minus E naught at the anode. So E naught for this cell will equal minus 0.44 volts minus a 0.80 volts for a total of minus 1.24 volts. And it is a non-spontaneous cell. So let's finish off and calculate delta G naught and K. We know that our E naught is equal to minus 1.24 volts. We know the number of moles of electrons transferred is 2. We're given Faraday's constant is 96,485 coulombs per mole of electrons. And so we know that delta G naught is minus NF E naught, and we simply plug it in. And this is going to give us minus 2 moles of electrons, 96,485 coulombs per mole of electrons. Remember, coulomb is just a unit of charge. For every 1 mole of electrons, you get that many coulombs. multiplied by a minus 1.24. And remember that a volt is a joule per coulomb. Our coulombs cancel, our moles of electrons cancel, and we're going to get a positive 239,000 joules for the value of delta G. Now notice this is consistent with the sign. E naught is negative, making it non-spontaneous. Delta G naught is positive, making it again non-spontaneous. This should also tell us that K is small. So let's try this. Delta G naught is equal to minus RT times the natural log K. 239,000 is equal to minus 8.314 multiplied by 298 Kelvin times the natural log of the equilibrium constant. When we solve this, we get K is equal to 1.3 times 10 minus 42. And this is a definitely non-spontaneous reaction. This is a tiny equilibrium constant telling us the reaction lies very much to the side of reactants.